Hello students, welcome. In this problem, we are going to learn how to find out the time period of oscillation for a spring block system like this. So mass of the block is m, k1, k1 and k2. So it is given like this. Now what they are telling is that the block is slightly displaced down and you just release it or set to free, it will oscillate. Now what is the time period? So we know basics of SHM, or for any SHM system, how to find out the time period. Find the restoring force, from there find out restoring acceleration, from there find out omega, then find out time period, then you can find out frequency. So for us, for us, restoring force finding only slightly tricky. Otherwise restoring acceleration, omega, time period, frequency, all are easy. So here I have to find out restoring force. Here restoring force due to one is K2, another K1 and K1, both are there. That is angle, they are slightly displaced in angle theta. Now when I move this down, K2 will compress vertically, the restoring force will be upward. Okay, and now what will happen? K1 will extend, the restoring force will along the spring only, but to find out the net restoring force I have to take the cos component. So you know the vector component, like if this is force is F1 and here angle theta, right? So this will be F1 cos theta due to the spring force of here. Same way here there will be a 2 times F1 of cos theta, right, due to this both the spring. And this one anyway, that is F restoring force remains K2 displacement. So please keep this in mind. We should take the cos component of the force along the spring. To find out the force along the spring, we have to find out the displacement also, right? So be careful here. When I find out the when I displace this block slightly down, the displacement, to understand clearly, I'll draw the equivalent straight line. So take this line as K1, this line is another K1, and the block is somewhere here. And now what happened is that there is an extension. So let me draw the extension due to down. So K1 slightly extended down and another K1 slightly extended down here. And thus what about the vertical one? So this remains same, right? So it's remains same. So this K2 remains same. So this is K2 vertically down, and here this is along vertical. Now from the diagram, if this angle is theta, this angle is also theta, this angle must be theta, this must be theta, right? So just to find out the extension, draw the perpendicular line. If you are drawing the perpendicular line, the K1 extension here is, let us take it as y dash, and another K1, this extension is here, it is y dash. So now the mid one K2 is there, right? That extension is y, that is vertical. Now I have to find out the net along the vertical, right? So how can I write this? This is y dash and this is y. How they related? Yeah, it's clear. So y dash is equal to y cos theta, right? From the right angle triangle, this right angle triangle. So this is also right angle triangle. Now here y dash is y cos theta. This is important point. The next one is I have to find out the restoring force. How can I write the restoring force? The restoring force, the net restoring force will be minus, okay. So here K1 2 times is there, so I am putting 2. So 2 times K1 y dash, okay, this is restoring force. What I need only cos component, so I am putting cos component. So this is restoring force, okay, due to single, and this is double cos component. I am taking that. Understood? Very clear. This is y dash, okay, the displacement along the angle theta. Please understand that. What is next one? Plus K2 y, because K2 only displacing along vertical, that displacement is y. Now what is the next step? I have to find out what is y dash. So if I substitute what is y dash, so minus 2 K1, what is y dash? Y cos. Already one more cos is there due to force. So cos theta into theta into plus K2y. Now you can understand what exactly happening here. It is simply minus 2 times k1. I have cos square theta plus k2 y. So I'll take y common outside because I need a restoring acceleration. So now you just see that I have one Paka restoring form. From there, I can write by comparing this, I can write what is restoring acceleration. What is restoring acceleration? The restoring acceleration will be F is equal to ma, simply, nothing big. So, and we know that the acceleration or restoring acceleration will be restoring force. So, the restoring force divided by mass. So, restoring force is simply 2k1 cos square. Again, I am repeating cos square coming 1 cos theta due to the force component, another cos theta due to the displacement. Okay, the displacement along the angle is y dash. I want to find out only in vertical, so that is y cos theta. So that is the reason why square is coming. This is a key point here. Plus k2 divided by mass into y. Now from there, so we found restoring force, restoring acceleration. Then what I have to find out? Omega. So what is the condition for SHM? In SHM, the restoring acceleration is minus omega square into y, right? That should satisfy this one. Just compare technically 1, 2, just take compare 1 and 2, write omega square. So if I write omega square, I can write directly a root of 2k1 cos square theta plus k2 divided by m. So this is nothing but omega we found successfully. Then what else we have to find out? Time period and frequency. We know the basic relation for a time period. So what is a time period? Omega is equal to 2 pi by t, right? Or I can write it as t is equal to 2 pi by omega. So I'll write the next step directly. T is equal to 2 pi root of a reciprocal of omega. So what is that inside? Like I put it as 2 times, sorry, m reciprocal m divided by 2 k1 cos square theta plus k2. So this is time period. If you take reciprocal of this, you will have a frequency.